2% times 100. Okay, you have to be careful though, because in an equation, we don't keep the percent symbol. So you either have to go decimal or fraction. I'm going to go ahead and go fraction. So 2 over 100 times 100 minus, there's that minus sign, 2% times x gallons. So I'm going to go with the fraction again, times x, plus, there's the plus sign I'm copying down, 100%, so 100 over 100, times x, equals, and go ahead and try write that one down by yourself. See what you get. Okay, so that should be 5 over 100 times 100. And there's our equation. Now let's solve this. Okay, so I don't like all those fractions, so I'm going to multiply out by 100 to get rid of those fractions. So multiply both sides by 100. When I do that, those twos cancel. When I distribute in the 100 to each of the 3 terms, that'll cancel out the hundreds on the bottom, and I will be left with something nice and clean. 2 times 100 minus 2x plus 100x equals 500. Let's go ahead and simplify. 2 times 100 is going to be 200, and negative 2x plus 100, 98x equals 500. All right, and then after that, subtracting 200 from both sides, we get 98x equals 300. Using your calculator, we get, it's not the nicest of numbers, 3.06. So x is about 3.06. And in our word problem, our answer would be, remember we have to write a sentence for a word problem. The answer is going to be, there should be 3.06, and what's the unit here? The units are gallons. Gallons drained and replaced. To obtain a 5% bleach solution. And period. Or exclamation point if you want. Please don't put a question mark. I'll wonder if you know if it's the right answer or not. Okay. And one more word problem to go. Okay, so this is a distance word problem. Okay, so distance problems, you can normally recognize them easily when you start talking about miles per hour or miles. Let's go ahead and read this. John drove from Edmond to Jamestown, a distance of 250 miles. He increased his speed by 10 miles per hour for the 360-mile trip from Jamestown to Crawford. If the total trip took 11 hours, what was John's speed from Edmond to Jamestown? Okay, let's go ahead. I'm going to draw a diagram. I always like drawing diagrams if I can. So we have Jamestown, and then he drives to... Oh, sorry, take that back. He drove from Edmond to Jamestown. Edmond to Jamestown, or Ton, depending on what you feel like the accent you're going to say. Okay, and so Edmond to Jamestown, and then he drove to Crawford. Okay. Let's see. All right. What do we know? This distance was 250 miles. And the other distance from Jamestown to Crawford was 360 miles. Okay, so it's a pretty good picture. So now I need to write my let statement. So normally your let statement, you base that off of the question. So the question says, what was John's speed? Okay, so that's the thing I'm trying to find, so let's use that as my let statement. So I'm going to say let. We could use S for speed, but I find it often get confused with a 5. So I won't use S, I'll use P. So let P equal John's speed from Edmond to Jamestown. And I'll go ahead and draw the little P right up here to indicate his speed at that moment. So then what would his speed be here? Well, what does the story say? The story says when he was driving from Jamestown to Crawford, he increased his speed by 10 miles per hour. So increasing by 10, if you were driving 30 miles an hour and you increased 10 miles per hour, that would be 40 miles per hour. So you add P plus 10. All right, so the next thing we're going to do is we're going to go ahead and I use this chart when I'm using distance problems. Okay, so there's a known equation, so distance equals rate times your time. So go ahead and draw those boxes in, and we have two different problems. We have from Edmond to Jamestown, so I'll do E to J. And then we have Jamestown to Crawford. So filling in these charts, do we know the distance from Edmond to Jamestown? We do. That distance is 250 miles. So I'm going to go ahead and write 250. Do you know the distance from Jamestown to Crawford? Yes, we do. 360. Okay, going pretty well here. Now, let's see. Do we know the rates? How fast they were going? Well, we kind of do. We know the rate from Edmond to Jamestown was P. And we know the rate from Jamestown to C was P plus 10. Okay, so when we're filling out this box, the last box, we always use the other ones to fill this in. Okay, so we're going to use D and R to fill in T. So we need to manipulate our equation a bit here to figure that out. So distance equals rate times time, and I want to solve for what time will be, which means I need to get time by itself. So let's divide both sides by R, and that means that D over R will be our time value. Okay, so try to see if you can fill in the box for time. So D over R, that's going to be our D value, 250, divided by my rate, which in our case is P. Okay, go try fill out this box. Okay, filling that out, it's going to be our distance, 360, divided by our rate, which is P plus 10. All right, and the last box we fill in, we are going to use this box for our equation. So, how do we put together an equation? What else do we have? What other information do we have that we have yet to use? If the trip took 11 hours. Okay, we haven't used that yet. So we know the total time. So total time is 11 hours. Well, that means that the time it took to get from Edmond to Jamestown plus, so this time, plus the time it took to get from Jamestown to Crawford, those two should equal 11 if I add them up, the total times. Let's go ahead and do that. 250 over P plus 360 over P plus 10 equals 11. So this is the time from Edmond to Jamestown, and this is the time from Jamestown to Crawford. And we have our equation. So the next thing we're going to do is solve it. Okay, so we have these fractions. So remember, our plan is we're going to find the lowest common denominator and then multiply across the equation by that. So, my lowest common denominator is going to be, well, we have this binomial here and a monomial there, and a 1. So, it's going to be, if you remember, P plus 10. Okay, and then multiplying everyone by that value. So P times P plus 10, P times P plus 10. Remember, I'm doing this because I want to get rid of the fractions in the equation. It's easier to work if we can get rid of the fractions. Okay, once I do that, the p's cancel there, so I'm left with 250 times P plus 10 plus For this one, the p minus 10s cancel, and I'm left with 360p equals, oh, nothing cancels here, so I'm left with 11 times p plus 10. Whew, but look, we got rid of the fractions. Alright, let's go ahead and simplify this a bit. We can use the distribution property, so that's going to give me 250 times p plus 250 times 10, which is 2,500, plus, that is simplified, equals. Once again, let's use the distribution property. And what do we get? 11p squared plus 110p. Okay, now let's start simplifying a bit on this side. So 250 plus 360. That, pulling out your calculator if you need to. If you can do that in your head, go ahead and do it in your head. That's 610. So 2,500 plus 610p plus 11p squared plus 110p. Okay, this is quadratic. So our goal, move everything to one side, and then we'll see if we can factor it or if we'll use the quadratic formula. So moving it to one side, minus 610p, minus 610p, and then subtract the 2,500. We get 0 equals 11p squared. That's going to be minus 500p minus 2,500. Okay, so let's go ahead and bring out some scratch paper, because I want to try see if I can factor this instead of using the quadratic formula, because we already did that on one problem. So why not, let's try factor. Okay, so when I'm trying to factor, if I look at this, there's this minus sign here, so that means I know that when I factor it, I'm going to have a minus and a plus sign, okay, because this is where the product comes from. And then in the end, when I add or subtract, I want to end up with a negative 500. So let's go ahead and look at the factors of 11 and 2,500. Factors of 11, those are very easy. That's just going to be 11 times 1. Okay, but the factors of 2,500, that is a lot. So my goal is to end up subtracting and getting a 500. So let's just choose some values of 2,500, factors, that are relatively close in size. Let's see. Well, 100 times 25 gives me 2,500. What's another one? 50 times 50. Okay, these aren't all the factors, but let's go ahead and work with these and see if they give us our answer. If not, we'll have to look for more factors. Okay, so here's the testing part. So testing. I choose a factor from the first one. Well, we're lucky. There's only 11 plus 1. Sorry, 11 times 1. And then let's choose the top one. Okay, so 100 times 25. There are two ways to test. First, you test the top. So 1 times 25 is going to be 25. 11 times 100 is going to be 100 and 0. Remember, there are different ways to factor. This is the way that I choose to factor. So if you have another method that works, go ahead and stick with that method. Okay, so my goal is to subtract these and end up with 500. That doesn't work. These guys don't subtract and get 500. All right, one way to go. We can multiply across. So that's going to be 100 times 1, 100. And then 11 times 25, pulling out my calculator. $275. Can we subtract these in any way to get 500? No. Okay, so that tells me that those factors did not work. We have one more go, and if this doesn't work, we'll have to find more factors. All right, so pulling down the 11 times 1 again. Now let's check with the 50 and the 50. Okay, so multiplying top to bottom, I get 50. Then multiplying 11 to the 50, what do I get? 50 times 11, so 550. Can I subtract these and get 500? I can. 550 minus 50 is 500. But remember, I wanted a negative 550. So this should be the negative, and that should be a positive. Because negative 550 plus 500 would give me the negative 500 I seek. Okay, so filling this in, remember the 11 times 1, those were our W values. Oh, sorry, P, not W. Okay, so if I have 11P and 1P, now when I fill this in, remember, when we're factoring, we're looking for the inner product, which is made up of the O and the I in FOIL. Because remember, in FOIL we have FOIL, so we're looking at these two. Okay, so filling this in, my 11P, that was the value multiplied to the 50. So 11P got multiplied to the 50, and the 1 got multiplied to the other 50. I need to check my sign here, though, to make sure it was okay. The 11 and the 50 were the ones that gave me the negative. Okay, so see the way I set this up here? That's not right. The 11 and the 50 should get the negative. Okay, so I'll go ahead and change that. So how could I check that my answer is correct, that I factored this correctly? Remember, we just FOIL it back out. So let's check 11P plus 50, and then P minus 50. So foiling. We're going to FOIL this out, not factor it. 11P times 11, P squared. 11P times negative 50 is going to be negative 550P. And then 50 times P is going to be 50P. And lastly, 50 times 50 is going to give me the 2,500, the negative. Simplifying this up, we get, okay, like terms, that's going to be negative 500P minus 2,500. Is that what I started with? Ah, it is. Awesome. So we factored correctly. Ooh, that was a lot of work. It's so much harder when the numbers are very large because you have so many factors to work with. So sometimes, if you're not told to factor, it's nice to use a quadratic formula if the numbers look nice. It's good to have options. All right, so lastly, we're going to set each of these to 0. So 11P plus 50 equals 0. Then P minus 50 equals 0, and we'll solve. So subtracting 50 from both sides, P equals negative 50. Minus 50, minus 50. 11P equals negative